Hello friends, today I'm going to solve LeetCode problem number 958, check completeness of a binary tree. In this problem we are given the root of a binary tree and we need to determine if it is a complete binary tree or not. So let's see what does it mean to be a complete binary tree. So let's take an example. So this one node, is it a complete binary tree? Yes, it is a complete binary tree because it's a single node is always a complete binary tree. What if we have two nodes? So the possible ways we could have two nodes in a tree is either it has one child towards its right or it has one child towards its left, right? So this is a complete binary tree, but this is not a complete binary tree. Why? Because in a complete binary tree, all of its children in the last level should be towards the left. All the children of all the nodes should be towards the left. So since this is the last level, the child it has is towards its left, right? But this the last level, it doesn't have a child towards its left. Actually it has it towards its right, so that's why it's not a complete binary tree. Let's take another example here. So we have three nodes. So obviously three nodes will always be a complete binary tree because it has nodes both towards its left and towards its right. Now what if we have something like this still has like a node towards its left, right? So this is towards its left, but however since this node doesn't have any children, and now we have a node which has a child. So while we traverse, we're actually traversing starting from the left. So while we're traversing, we traverse this node first and this node next. So here while we're traversing, even though there is a null, we will traverse the children of this node first. So when this is a null value in a complete binary tree, we expect that there will be a null value in all the other, like null value for all of its other children. However, we encounter a value here, a node here, so that would mean that this is not a complete tree. For this tree to be complete, it should be something like this. So that one node should be here. So if that's the case, this would be complete because now we traverse from left. So we traverse this in this way, we found all the nodes, and then next while we're traversing from left, we encountered a node, and then after that we encountered a null value, and after that null value we do not have any nodes, right? So that is when this tree will be a complete binary tree. So now let's see how we could solve this problem actually using an example given to us. So here we are given an example. So what are we going to do is we are going to traverse each of the nodes one level at a time. So that would mean that we are using breadth first search. So we perform a breadth first search starting from the root node, and for that we are going to create a queue and push the root node to our queue. And then while the queue is not empty, what are we going to do is we are going to pop out each of the element from the queue. So that would be in first out order. So the first in first out order, since one was the first element we pushed in, so that is what we are going to take out. So now for one, we check each of its children, and we found that it has a left child, so we push that value to our queue. It also has a right child, so we push it to our queue. And now 2 was the first one to get in, right? So we pop out the queue and then check for its children. So now 2 has a child 4 towards its left, so we push the value 4 to our queue. Next it has a value 5, so we push the value 5 to our queue. And then now we pop out 3. So for 3 we have its left child, so we push the value 6 to our queue. And now since it doesn't have its right child, what are we going to do is we are going to push the value null here. So once we did that, once we encountered a value null, what are we going to do is we are going to set a flag That is, we found a null value, we encountered a value null to true, so we set this flag to true. Now this would indicate that this is the point where the tree should end, but now we keep on going. So we traverse the node 4, so this is node 4 and it doesn't have any children, so we do not do anything. For node 5 we traverse it again and it doesn't have any children, so we do not do anything. Next we encounter node 6 and we traverse it and we do not do anything. And then finally we encounter the value null, so we are not again doing anything because that's a null value, null node, and that is when our queue ends. So finally we knew that everything went by smooth, that is from left to right, all the nodes had their children towards its left, right? So that is when we return a true. But let's suppose there was something different in this case. Let's suppose that we had one more node here. All right, so we had one more node here. So while we are traversing 3, we know that it had a node 6, it had a null node, right? We encountered a null here, so we pushed the value null. Now we did that while we were traversing node 3, right? While we were traversing this node. So in the next step we would be traversing node 4. So while we traverse node 4, we find that it has a child. So it has a child, and we would push the value of the child. Suppose that is equals to 7, so it is 7, so we push the value child in our node. And then next we traverse another node, so after 4 that would be 5, so we traverse 5, it doesn't have any children, we don't do anything. We traverse 6, we don't do anything. Now we get a value null, so once we encounter null we set our flag value to true. So now this would indicate that the tree should end at this null value. However, when we traverse the tree we find a value which is not null, so that would mean that the tree is not complete because we found a value even though we encountered our null node way before that. So that is when we are going to return a false. So that is how we are going to solve this problem actually. So let's dive into coding. So we need a queue, so we create an array and we push to our queue the root node that we have. And in our constraints we have been given that the tree will have at least one node, so that would mean that our root node will never be a null value, so we could just push this without any concern for the null value of the root node. And then we are also going to create a variable flag, so let it be null found equals to false, set it to false. And then while the queue is not empty, so we iterate over the queue, we pop the first element from the queue, so let the node equals to queue dot shift. So we take the first element from the node queue, and if the node is a null value, that is if we encountered a null value in the queue, so that is when we set our null found to true. So we set it to true. And next, if our null found is equals to true but the node that we encountered is not null, that would mean that we encountered a null value before, but next we encountered a node that is not null, that is when we return a false, right? So we return a false. Else what are we going to do is we don't need an else case. If node is not null, then we push the left child, and if the node, okay, so this will be the same if condition here. So we push the right child next. So why are we checking for this node is not null? Because if it were null, then we could not find its left child and right child, and that would give us an error stating that we are looking for property left for null value. So now we have our while loop set. We are finally going to return true if everything goes fine with the while loop, else we return a false if we found a null value and a node after that. Now let's try to run our code and look for any errors. Okay, so there are a lot of errors. What went wrong? Let's see. Oh, okay, we need to push it to the queue. All right, let's try to run it again. Oh no. Okay, so we actually need this thing here. Great, so it's accepted. Let's try to submit this. And all right, so the time complexity is O of n because we are traversing each of the node, and the space complexity would be also O of n because we create a queue to store our children.